So in class we did a couple of examples of the sample distribution for a categorical variable, but it's just one thing that the more examples you see, generally the easier it becomes. And so we're going to do a couple more examples here in this video. So in our first example, we're going to assume that in reality 54% of people prefer Papa John's to Pizza Hut. Or in a sense what I'm sort of saying here is I'm going to say that my P, that's of all people, 54% prefer Papa John's to Pizza Hut. So I'll say that's, as you know, those that prefer the Papa John's there. If we were to randomly sample 180 people, so we have our N, what is the probability that Pizza Hut was preferred in the sample? Now, just reading that question can be a little hard, so we're going to kind of break it up into pieces. So we're going to do a couple things before we actually find that probability. So the first thing we're going to do is actually find our sampling distribution to make sure we can utilize the idea of the normal curve rule. So we have our N, we have our P. We're going to go through and check our conditions. So do we have a relatively random and unbiased sample? It says they're going to randomly sample 180 people. It doesn't really tell us anything else about that. So at least from what we know, there's no known bias to what they're doing. So that will seem okay. Then we need to check to see if our N times P is at least 10. And we have our values. So our N is 180. Our P is 0.54. We do our math. We get 97.2, which is at least 10. And then we take our N times 1 minus P to check out that also is at least 10. So we get our 82.8 for that. Now just a reminder what those numbers actually are. So if we're to sample 180 people, we found out 97 of them are going to prefer Papa John's. The other 83 are going to prefer Pizza Hut. That's just what those two numbers really are. So because that's true, we can say that our P hat is approximately distributed normally with the mean of P, which is our 0.54. I need to do my little standard deviation calculation, which was the square root of P times 1 minus P over our N. Which is 0.0371, so that's going to go up here for us. So our sample distribution is done. But now, so we were talking about people that preferred Papa John's to Pizza, but we actually want to find Pizza Hut being preferred. So what does it actually mean for Pizza Hut to be preferred? Well, that would mean that the percent that prefer Pizza Hut would be bigger than 1. Okay, so if more than 50% prefer Pizza Hut would be preferred. Right? I can also phrase that in a slightly different way. If the preferred for Pizza Hut would be at least 50%, the percent that prefer Papa John's would have to be less than 50%, right? This is really saying the same thing. Why am I focusing on that? Well, up here we were talking about Papa John's. So what this is telling me here is that if P hat is less than 50%, Pizza Hut is going to be preferred. Well, let's take this idea and apply it to our picture idea first. Alright, so we're going to start by just drawing our basic picture using just our mean and standard deviation that we found when we did the sampling distribution. So our mean is at 0.54, and then we're going to subtract off that 0.0371 as we go to the left. We get 0.5029, 0.4658, and 0.4287. And we're going to add it going up in the other direction. And 50% is sort of our key number, right? So I kind of look at about right there. And so here's what I know. So 50% is sort of our key number. So if it's 50-50, nothing is really preferred. If it's more than 50%, Papa John's is going to be preferred. Versus if it's less than 50%, Pizza Hut is going to be preferred. And so what am I actually trying to find? Well, I'm trying to find Pizza Hut being preferred, so it's going to be that tail. So on this one, it's just come up with a picture. Usually once you know the picture, we're good. Because our next process is to find our Z. And our Z, we take that number along the bottom that we drew, so our P hat is going to be our 0.5. Our P, where the graph is centered at, is our 0.54, this number that we use from the very, very beginning. And we're going to divide by our standard deviation that we calculated already above, of this 0.0371. We get our Z to be negative 1.08. Right, and then we always go to the table with our Z. Find out what we get. So just pull up our Z table that we're used to here. Find our negative 1.08. So there's the 8 column. Negative 1.08 will give me this 0.1401. Now, is that our answer, or do we need to do anything to it? Well, the table is shaded left. Our picture is also shaded left. So that is actually our answer. 0.1401. Finally, let's write out what that actually means. And I do expect to see these interpretations. So if 54% of people prefer Papa John's to Pizza Hut, which is what our P being 0.54 is telling us, the probability that Pizza Hut is preferred in our sample of 180 people is our 0.1401. So if you are a Pizza Hut fan and we have 180 people, there's about a 14% chance that we are going to actually order Pizza Hut if it comes to a vote. Right, that's the idea of that number we just found. Okay. One more example. Alright, so suppose that a mail out flyer for a given business brings in about 3.5% of all those that receive it. So first thing again we're going to do is make this 3.5% a decimal. That's 0.035, so you can just divide by 100 to get that decimal if you're struggling with that. That's going to be our P, right? It's of all people that receive it. The goal for this business is to bring in at least 30 customers. If they send out 1,000 flyers randomly, what is the probability that the business meets its goal? Right, so we're going to send out 1,000 flyers. Let's first actually check our sampling distribution conditions here. Alright, make sure we can actually do this. Again, it says we're going to send out the flyers randomly, so at least from what we know, there isn't going to be a bias here. We're going to check our N times our P. We get 35, which is at least 10. Check out N times 1 minus P. 965, which is also at least 10. And here are those numbers. So if we send out 1,000 flyers, we're going to expect about 35 of those customers to come in and 965 to not come in. Right, so that's what those numbers again are telling us. Since our conditions are met, I can say that my p hat will be approximately normally distributed at the mean of p, which is our 0.035. And then I need to find my standard deviation here. I'm doing the math here. We should get 0.0058. So that number is going to go up here to be our standard deviation. Now the main reason why I did that was so that I can draw my picture to help me understand what's going on here. Figure out what probability am I really trying to find. So we start by putting our mean here on the picture. So our p is just 0.035. Our standard deviations are 0.0058. So we're going to go to the left by those numbers. So subtract off 0.0058. Get 0.0292. We'll do it again. And do it again. The same thing with adding it on. And there's our numbers that we get. Now we want to find out the probability that we meet our goal. Bringing in at least 30 customers is our goal. Well, we're bringing in 30 customers out of how many? Out of 1,000, so I gotta do my little division there first. So I'm gonna find 0.03 on my picture, which is about right here. So there's our 0.03. We want to bring in at least that many customers, so we're gonna shade to the right. Alright, so what would be our next step? Gotta change that to a z so I can go to the table, right? So we take our p hat, which we just found to be our 0.03, subtract off our value of p, or where the graph is centered at, 0.035, and divide by our standard deviation that we already calculated above, 2.0058. Get our z. So we're not quite one standard deviation below or to the left. I'm going to take that number to the table. So here's our negative 0.8. There's our sixth column. So we're going to find 0.1949 from our table. But again, remember that's what's to the left of that number. So that's over there. So my actual probability, that means the 1 minus rule since we're actually shaded right. And of course now the last thing we want to do is make sure we can interpret this number. So if 3.5% of all customers who receive the flyer come in, Alright, so we're taking that idea of, we're assuming that really that P is 0.035. The probability that they will bring in at least 30 customers with 1,000 flyers is our 0.8051 or an 80.51% chance. So a little bit more than an 80% chance that they are going to meet their goal if they send out 1,000 flyers. So they can decide if that's enough flyers or not to get at least their 30 customers. So we'll be doing another example in class before you take your quiz, so make sure if you have questions that we are asking them.